Okay guys, so here is another example. In this example we need to use loop or mesh analysis to solve for I1, I2 and I3. Okay, so in loop analysis or mesh analysis we apply KVL, Kirchhoff voltage law, to find out those loop currents or the currents in each mesh. So here is mesh 1, okay, and here is mesh 2, and here is mesh 3, and we are going clockwise. So if we start from this corner here and we go there, we have this voltage drop. Now we are assuming that the current I1 goes like this through this resistance. So we know that this is the polarity plus from here and negative from here according to our current. This is our source. Now here we have positive negative for I1, but we have to pay attention that this branch or this resistance is mutual between two loops, two meshes, and from the other side we have this voltage drop because I3 goes the other way around. So we have here two voltage drops or their difference. The same thing here. From the point of view of mesh 1, this is plus and minus, while from the point of view of mesh 2, this is plus and minus. Now we have voltage drop, voltage drop or rise, voltage drop or rise, voltage drop or rise, and so on. So let's write these. Now this is, as you see, plus and minus. So 4, so that's loop 1, 4 multiplied by I1 plus 3, which is the source, the battery, plus 9 multiplied by I1 negative or minus I3. That is this resistance and multiplied by the two currents, and that is this voltage drop and this voltage rise, or as you look at it, plus 3 multiplied by I1 minus I2, all that equal 0. So this is from loop 1, equation 1. If we rearrange, that is 4I1 plus 9I1 minus 9I3 plus 3I1 minus 3I2 equal minus 3. Again, we add 4I1, 9I1, 3I1, that is 16. I1 negative or minus 3I2 and minus 9I3 equal minus 3. And this is equation number 1. Okay, now we look at loop 2, this one. We have minus 10, this is this source, plus 3I2 minus I1. This is taking place here. Then we have this part, plus 9 plus 2I2 equal 0. This is the 2I2. Okay, again, if we rearrange, there is 3 times I2, 2 times I2, negative 3 times I1, so it is negative 3I1 plus 5I2 plus 0I3 equal, because we don't have any I3 terms here, negative 10 plus 9, that is negative 1. When we pass it to the right side, it is 1. And this is equation number 2. Now in loop 3, we have again 9 times currents 1 and 14. So negative 9 plus 9 times I3 minus I1. This is taking place here. Then we have plus 1 times I3. This is the 1 ohm resistance times the I3. So it is I3 minus 14 equals 0. Again, if we rearrange this, there are no I2 terms in this case, and we have negative 9 I1. There is 9 I3 and I3, that's plus first 0 I2, there is no I2 terms, plus 10 I3 equal negative 9 and negative 14 is negative 23. To the other side, that's 23. And this is equation number 3. Okay, so now I will rearrange the equations, and I just clean up a little bit and arrange the equations. Okay, so these are the equations after we cleaned up a little bit. Now for this one, there are many ways to solve this system of equations. It is a simple system of equations. By hand, the easiest way actually is to substitute. So if we for instance write I3, this I3 in terms of I1, and the result we put it here, then this I2 in terms of I1, and again the result we put it here, we will have this equation in terms of I1 only, and we solve it. So this is one way, and we will do it like that now, and I will show you a different way using the inverse of the augmented matrix using Matlab. So this one, if we rearrange this one, we get that I3 equals 23 plus 9 I1 over 10. Right? If I take this to the other side, it becomes plus. It is negative, becomes plus. So here it is, and divide by 10, we get this is I3. All right. Now from this equation here, okay, what we see that I2 equals 1 plus 3I1. Okay, because we take this part to the other side, so it becomes plus over 5. Right? And now we just substitute these values of I2 and I3 in this equation number 1. This gives us the following: 16 I1 minus 3 multiplied by I2, which is 1 plus 3I1 over 5, and minus 9 times I3, which is 23, plus 9I1 over 10. All of that equal minus 3. So this is one equation with one unknown, that is I1. Okay, and we just need to solve it. So this is negative 3 times 1 is negative 3 over 5. Negative 3 times that is negative 9. Okay, let's do it, although this is a trivial thing. Minus 3 plus now this is negative times negative, it becomes a negative, sorry, times positive keeps us negative. That's negative times that. So this is negative 9 I1 over 5. Here negative times this is negative. That's 207, I guess. 9 times 20 is 180. 9 times 3 is 27. So it is 207 plus, again it is negative, sorry, negative 81 I1 over 10 equal negative 3. If we multiply everything by 10, we cancel this one, we cancel this one, we have here 160 I1 minus 6 minus 18 I1 minus 207 minus 81 I1 equal negative 30. So now we take the similar we take down those numbers, this negative 6, negative 207 to the other side, and we add up those. We end up with, so after arranging those or adding up the I1 terms and taking the numbers to the other side, we see that 61, the remaining is 61 I1 equal 183, and that means that I1 equal 183 over 61, which is 3 amperes. Now if we take this result of I1 and substitute this in any of these, here we get I3, substitute this here, we get I2. And if we do that, for instance, for the second one, minus I3 times 3 plus 5 I2 equal 1. That means that 5 I2 equal 10, which means that I2 equal 2 amperes. For the last one, negative 9 times 3 plus 10 I3 equal 23. So this is 27. Take it to the other side, it becomes 50. That means I3 equal 5 amperes. And this solves the problem or finds out the needed values. So I1 equal 3, I2 equal 2, I3 equal 5. Now what is important is to realize that this is this circulating sort of current. If we need this current here in this branch, okay, we have to take care of the fact that this current here is I2 in that direction and I1 in this direction. So it is I2 minus I1, and that means the current here is negative 1. It is actually 1 in the other direction. For this one, it is 5 in that direction, 3 in this direction. In reality, there is 2 amperes moving in this branch or in this resistor. Okay, so this is one way of solving this. Now in terms of solving linear equations, this example is easy, and we have done it using our pen and paper. Sometimes it's much easier to do things using computers or calculators, and Matlab becomes very handy in solving such problems. So here is Matlab, and just to show you how you can solve this equation, I'll just change the font, make it bigger a little bit. Okay, so we say that the augmented matrix A equals this augmented matrix in the problem. So it is 16, -3, -9, then -3, 5 and 0, and -9, 0 and 10. So 16, -3 and -9. That's one row, the first row. The second row is -3, 5 and 0, -3, 5 and 0. The third row is -9, 0 and 10, -9, 0 and 10. So this is our augmented matrix, we can call it and see it. That is A. Now the right hand side matrix B, it was, or vector, it was these numbers, -3, 1 and 23. So for that one we say it is -3, 1 and 23, and here is B. And now to solve this we say either inverse A times B, that gives us I1 is 3, I2 is 2, I3 is 5 amps. Those are actually the numbers that we got here. Okay, another way you can say A and \B, it should give us the same answer, 3, 2 and 5. Okay, as you see, it is much faster to use computers or calculators to solve such problems. Okay guys, see you in another example. Thank you for watching.